Okay, welcome everybody. Let me touch first on the solar news for this week. February 15th. Can you imagine? All right, what I've got is, this was an interesting article I ran across. 3G, you know, a lot of the cell operators are rolling out their 5G networks. And apparently, in order to make space for the bandwidth, they're simply shutting down their 3G systems. And a lot of the installed inverters rely on 3G to communicate.
Go in the crate.
So, so what we're running into
You can look
is that the inverters are not working. So, so when the 3G gets shut off, these inverters will stop reporting, and that may affect the warranty. So there's a new app by Sunray or Sunvey that's supposed to go out there and identify which inverters that you're linked into your systems are no longer reporting because of the 3G thing. I went online and I tried that. And it did let me register Endphase, but then it asked me to register also Solar Edge. I don't have any Solar Edge systems that I have the information for. And it required an API key for the Solar Edge system. And since I couldn't provide it, it wouldn't let me proceed. So, so I just got stuck in the water. It seemed like a really kind of goofy system it's a free app that you're supposed to be able to log into to track your system to see if they're affected by the 3G thing. But I couldn't go forward because it required both Endphase and Solar Edge at the time of registration. So it may be really buggy, I don't know, but it's something to look into if you've installed a number of systems, and make sure that the communication through the wireless network is still working. The California CPUC, the California Public Utilities Commission, updated their renewable portfolio standard, and they increased it to 86% renewable by 2032 and 100% by 2045. The whole CPUC seems schizophrenic, because remember, just a couple of weeks ago, they were talking about gutting their net metering laws, which was going to devastate their renewable energy industry. At the same time, they're increasing their portfolio standards. And then they did an about face and they got rid of the whole, they call it net metering or NEM 3.0. So because there was such a huge backlash against them, they backtracked on all of that. There's another article in that same vein that reported that $1.7 million was spent by 3 California utilities on lobbying to push through that net metering 3.0. And one of the provisions, other than lowering it from retail to wholesale on the net metering, they were also going to increase the access fee to $64 per month, just for grid access for a typical 8 kW system. So a lot of the people, the solar advocates, basically said this would reduce the industry, cut it in half, essentially. And now the utilities are claiming that solar adds $200 per year to every household in the state. They didn't seem to have any way of backing up that number. They just throw it out there saying solar is costing the typical California utility customer $200. And in response, Lawrence Berkeley National Labs did a study. Effectively, they said there were about 16 statewide studies that disprove that there's any negative impact of solar or net metering policies on utility customers. The Lawrence Berkeley National Labs found that in 40 of the 43 states that they studied, having a net metering policy such as the one in California had negligible impact on utility costs. So these utilities are pushing back with the same old thing of it's adding costs to your neighbor. It's trying to turn customer against customer. And it's part of that typical backlash that we would anticipate. So let me see. It seemed to me there was one other thing in the whole net metering. Oh yeah, Florida. We were talking about Florida here before we started recording. There was a big protest in Tallahassee at the Capitol, protesting Senate Bill 1024 and House Bill 741, which is legislation that's out there that's looking to gut the net metering current status in the state of Florida. They would again add higher access fees. They would lower from retail to wholesale, generation wholesale compensation, which in this case would cut the compensation by 2/3. So currently, if you're paying 12 cents a kilowatt hour retail, you get a 12 cents a kilowatt hour credit. But what they would say is you'll pay 12 cents and they'll pay you 4 cents or whatever they've determined is their generation wholesale cost. So that would have a big impact. Plus, the utilities would be allowed to simply deny you any net metering under this provision. They're claiming, again, like all these utilities, that it costs them money to service solar. Although Florida Power and Light, who is mainly behind this, made record profits in 2021. So it's hard to know how they're justifying this pushback, other than apparently all these utilities who are flush with cash are deciding to use that money to lobby legislators to get rid of any kind of competition. So this is just going to be an ongoing saga, I'm sure, that we'll be dealing with. And Endphase announced that their IQ8s are now ready to participate in virtual power plant testing. So we've talked about virtual power plant before. A lot of these utilities are starting to test out to see, can they use the integrated batteries that are out there in people's systems as basically a virtual power plant. I think that's all the news. I jumped around a little bit. Oh no, there's one more thing. This was a pretty cool new technology thing that I just saw. California, there is a water district, the Turlock Irrigation District. They're looking at covering the canals in their district with solar, which, if you know California, they've got all of those sort of concrete canals that are feeding water across the state for irrigation. The idea is the infrastructure is in place. You can put solar canopies over top of these canals, which will reduce evaporation, which is a big deal. Also keep the panels cooler, and then also generate electricity. So what they were showing is that this initial program is going to be done in 2024. There are apparently 4,000 miles of canals in Southern and Central California. They estimate that if they covered them all, it would save about 63 billion gallons of water, which is enough to meet the water needs of 2 million residents. And it would represent about 1/6 of the current installed base of solar in the state of California. So we've talked about, photovoltaics, where you put solar over water. The picture I saw, it actually spans the canal. So it's not floating on the water. It's like a canopy that just reaches across the canal. But that seems like a really cool, practical idea to me. I just was interested in that particular technology. Okay, any other comments from things in the news at the moment that other people may have that I missed? Give you just a second. Couple other announcements here. It seems like there are a bunch of webinars coming up, which I wanted to make you guys aware of. I don't want to give the details right here, but if you're interested in any of these, just drop me an email and I'll send you the link. But tomorrow, Tygo is having a webinar on module level power electronics, which is something that some of us may be interested in. March 3rd, Solar Energy International is hosting one on solar workforce development. So they're the group out of Colorado. On March 4th, there's one that Don sent me from that's on the impact of distributed energy resources. That's sort of a generic term, DERs, DERs, which is basically solar arrays, wind turbines. What is going to be the impact on this? This is from the Institute for Policy Integrity, which I looked up. It's like one of those generic names that could be, you know, something terrible. So I decided to look it up. And it's actually a nonpartisan.
Didn't trust me, Jay?
I don't know. It could have been your favorite Fox News host's personal pack or something.
It's from NYU. How much more liberal can you get?
I know. Yeah, I was thinking it says nonpartisan, and then it said the New York School of Law, and I thought, well,
yeah, this nonpartisan is a relative term.
Yeah, I mean, it works for me, but I don't know about for you. And then for those of you who are a little more local, to me anyway, Wealthworks Institute is having a clean energy seminar on expanding the renewables in the Buckeye Hills region, which I just thought was interesting, that now we're starting to see local regional development organizations talking about how can we identify and expand renewable in a very specific, and this is part of the Appalachian region. Last week I had mentioned with the SREX, you know, going in and registering your SREX and how you can do that with, I think it was SREX Trade. Anyway, I went through it. I went through the process, and I promised you I would update you a little bit on that. I filled in all of the information, and then it came back to me and said, guess what? You don't have a investment grade meter to monitor my system. So my system uses Endphase. So I was just using the standard Endphase Enlighten monitoring system, which they rejected. Apparently you've got to have those little CTs installed on your service panel box in order to measure the amps going in, the amps going out, and my system's old enough, I don't have those. So I just thought I would mention that if you've got an older system that you're trying to register, you might have to deal with the whole investment grade metering. Most of them, when I looked up, like Solar Edge, the new Endphase combiner box, all of those have whatever meters are required. But I first installed mine in 2014, and it doesn't meet that requirement. Okay, then the other thing we said we would talk about is the return on investment discussion that Bob had brought up. And Bob had submitted, and I had sent it through to Don and a couple other people. I think Bruce, you had gotten it. Let me see if I can bring this up. Yeah, let me see. I'm going to have to. So Bob, why don't you recap that while I'm bringing up the document? Are you there, Bob? Whoop.
Are you on mute?
Did Bob disappear on us? Okay, Don, did you get
there? There you go.
I'm here.
Okay, Bob. Yeah. Why don't you recap what you were trying to do with that?
In my sales presentation,
This top number, the telephone pole. This is this house here.
Oh, okay.
Right here.
somebody has their mic on.
Yep, I just muted.
Thank you. In sales, I can't believe that. I believe that the best way of selling is to say a return on investment is better than market value. And that's what I'm seeing. But I'm probably maybe doing something wrong, and that's why I'm presenting it today, so I can have other people look at it. But forget if it's solar. If you have money, this is a great way of spending your money, and the return on investment that you get is not taxable. So my fear is that I stand up in front of the people at the library and do my PowerPoint, and then I get crushed to death.
Okie doke. Well, I'm sharing the screen of what you set up. Can you guys see this? The return on
Yes.
investment spreadsheet?
Mhm.
All right, so what you're saying here, Bob, is you've got the initial cost and you're estimating at $2.75 per watt, which is, pretty industry standard at the moment. You're saying that in this particular example, it's a 7.5 kW, which would produce about 10.5 thousand watt hours per year, 25 year, offsetting those. So I think it's pretty self-explanatory. The one question I had on it, I didn't understand the Illinois Renewable Energy Certificate Program that well. So I kind of had to take your word for how that's generating. I didn't know where you got the 157 REX from.
Okay, so in Illinois, they pay you for 15 years of output at 10.5 kilowatt hours per year times 15. That to come up with 157 REX. One REC being 1,000 kilowatt hours.
Right. Okay.
I called this company called SREX Trade,
Uh-huh.
and they have a graph that they gave me, and for Chicago area, it's $64.56. If you go downstate, it's $79 per REC, and that's because the cost of electricity downstate is, believe it or not, is higher than Edison, which I can't believe, but it is.
Bob, let me ask you, how did you, I had a couple of technical ones, but just on that rec calc, how did you figure out how many recs you were getting? I mean, it's the 40%, I get that. Or well, actually, I don't get that. What?
Yeah,
Okay.
he's saying that you're generating about 10 RECs a year and it's for 15 years. So he ended up
Okay.
at 157.
Okay. So that's how you get, okay. That
Yep.
makes more sense now. Another question I had is, you've got the electric bill payments at $200 a month. Is the 7.5 system, is that enough to cover? I'm just thinking without a battery, you're only getting it in the day. Is the $200 a month just the savings, or what you figured your entire utility bill will be? I mean, how you estimate that?
For the sake of this discussion, if you take a look down here, it says 10.50 required. So I produced a system that equals what the requirement is at $200. Illinois, we're paying 25 cents a kilowatt hour.
Mm-hmm.
And that's twice what Florida, I'm paying in Florida 13 cents an hour here.
Mm-hmm.
So that is probably one of the first factors that will change drastically the numbers here. But I'm using Chicago rates, and if the person uses less electricity, then I can downsize the system that way. So this is my first time through with this thing.
Okay. And I guess my two questions had to do with, you're showing a annualized 2% increase on your electric bill each year. So you're escalating your savings. I wondered if 2%, I know that's what they use, but we've had the discussion before because the cost of power is coming down. Is that a fair assumption? Are we going to begin to see a stabilizing of electric rates, and that 2% is maybe too aggressive for increases in electric cost?
Well, I got that information from my major source, Jay Warmke.
Yeah, well, I know they use that. They use that a lot. And since you're trying to sell, it's not a bad thing to say, okay, historically, we've seen a 2% increase in electric. It may just prove that it may prove to overstate when you look back in 20 years. But by then you'll be permanently retired in Florida, so you don't care, right? After you've sold the system. So.
No, I'll be permanently retired at that point.
Okay. And
But I can make an argument for the opposite, by the way, because what I see popping up is usage charges, multipliers of the maximum amount of usage during that day. And in the industry, I paid that all of the time. They took my business, but I was a manufacturing business, so I use a lot of power. And they took my highest at between 1 p.m. and 4 p.m., but the highest wasn't. They use it as a multiplier. Now I see that going in individual too.
yeah, so they're using what do they call it? The demand charges. Demand charges for commercial, and you're saying we're starting to see that in residential as well.
Yeah, and the other thing is that my usage last month in Chicago, because I had my thermostat turned way down and everything off, I paid $23 usage and $27 in fees. So, and those fees are coming up all the time.
Yeah. Well, one thing that I did notice that I would incorporate into this as a factor, it's a small thing, but operation and maintenance charges against the system. You don't have any care and feeding costs. There is some maintenance that's required. Not a lot. I was looking online. It seems to me utilities factor in about $11 a kilowatt for their systems per year. So you might throw in a number like that, which will end up coming in at $150 a year, just for things like, I don't know, weed control or changing out an inverter if you have to, or, doing an annual inspection, something like that.
I do have that in my cost, initial cost.
Well,
$500 on there.
where's that at?
That's part of the cost of 21,000.
The 21,625?
Yeah.
Couple comments on that too, Bob. I see you've got your first year bill savings in that column, but you've also got it in the payback columns over here on, I can't point to it. I'm pointing on my computer. You've got it in both places. You've got it in your first of your 25 years, as well as in your first year cost, and you're reducing your initial investment by that amount. That's typically, you would not put that in the ComEd line charges and the first year savings. Those would typically not go in your initial cost columns, and that'll change your ROI and your payback.
Yeah, most of the people who sell it says, okay, you get a federal incentive, and then you get your REC program. You don't get that until basically at the end of the year. It's a yearly thing.
Agreed. Well, you can reduce your.
Realize that. So they don't realize that initially. They realize it at the end of the first year. So I drew a line at the end of the first year when they get all of their rebates, and then I picked up at the second year under gains.
But what I'm talking about is the first year electric bill savings and the ComEd line charges. Those are annual charges. They don't really go into your initial cost.
But you still get that back.
Right, and you're counting it twice. You're counting it in that column, and you're counting the column to the right where it says year one.
Okay, well, why don't, Don, I'll have you guys, you and Bob will work that through without the rest of the group here, but I guess I just want to recap. Looks pretty good here to me. Now, of course, if you're talking commercial systems, you're also going to have accelerated depreciation, things of that nature that you can add in. This is residential, I assume. But I guess just looking at it in total, we can see that based on this in Illinois, you're basically telling them they're getting a 12+% return on their initial money as compared to if they stuck it in the stock market or in a certificate of deposit.
To be clear, that return is a lot more than 12%. That's
Yeah.
like a several thousand% if it's
It looks-
$80,000.
I got a question too. Just to make
I
sure.
want to understand what Mike Don just said.
The return you've got there, you have to have a discount rate, but you're saying that $80,000 on a $4,800 investment, that's not 12%. That's like thousands of percent.
I use the calculator, the calculation online.
I'm sure the calculator is there, but something tells me the input data might be, we might want to talk about that.
Yeah, that seems like, well, you're getting a 20-fold return.
Right. Which
So
would
that's
be-
got to be almost 100% a year, you
right,
know.
more, well, probably 50% a year. Look at it, just if it's only $4,800 and he's getting $2,400 in savings every year, that's about a 50% return every year.
But what about the rule of 72?
Once they had calculators in place, we kind of go ahead and put in real numbers and not estimate it.
Well, that's
Okay,
what I did. I saw it.
okay, yep.
So-
Okay, so why don't you look at that? So Eric, you had a question?
Yeah, I just want to make sure I understand this correctly. So you're getting electric bill savings of $2,400, but then wasn't that because you were totally producing all of the electricity you need? Are you also double counting that you're selling extra as well? Or how does the REC program work?
Oh, the RECs, yeah, you don't sell your energy. You just sell like carbon credits using
Oh,
the
okay.
REC program. So yeah, that is, you know, you're making the argument that the utilities make against these REC programs. Listen, you're making me pay for something, but I'm not getting anything in return other than the right to write off as against my portfolio that some of this power is being generated renewably. So it is like a carbon credit.
But they
Okay,
have to
cool.
have it.
Yeah, they have it in Illinois and they have it in basically 6 other states now,
Yeah.
the rec market, but it's something that's very much limited. But Illinois has really made this program lucrative, but this pool of money is not infinite either, is it, Bob? You know, that money is there until it's gone.
Well, what happens is that you put up 5% of the gross into SREX Trade as a bounty, and if you don't meet what I calculated and gave to my customer, he has to pay, because it's his system, out of that, or he'll get it back in 15%.
Right. No, what I was getting at is though the state of Illinois allocated just a certain finite amount of dollars. And then once that money's used up, this program stops.
So only so many people get it, not
Yeah.
everybody.
The good news is it's not run by the state, and SREX is not run by the state, so it actually works. And in the past, they got the money from ComEd,
Oh,
but this year they're getting from the federal government is sponsoring it now.
okay. All right. Well, hopefully, because I know that was a big concern in Illinois before, that the money ran out almost as soon as it was available. You know, everybody signed up quick. Okay. Any other questions on the return on investment? The numbers, other than your percentage there that you can work through with Bob, I think it all looks pretty good. I've been doing a lot of commercial assessments and I find the payback, I haven't been putting a return on investment, but I've been putting how many years it takes to pay off the system based on your energy. And with the current programs where I'm looking, it's about a 5.5-year payback for most of these systems, given the incentive programs. So quite a good return. The big question is, do people have the cash up front to make that investment? You know, a lot of businesses are running close to the bone, so they, you know, don't have an extra $20,000, $30,000, $40,000 lying around to install the system, even though they're going to get a great return on the investment. So,
But there is a way of, when they asked me if I finance, I said, no, I'm an installer. I give them help on financing, but there is a way of doing financing where you don't get your return on investment. You just start getting money back because if your interest rates are lower than the return, you can get on the positive side of the curve.
right, if you're taking out a loan and your loan payments are actually cheaper than what you would be paying in your electric bill, then that's definitely a good return. And for instance, the REAP grants through the USDA, if you're an agricultural business or a business located in a city less than 50,000 people, you can get a 25% grant from the USDA or 75% low interest loan guaranteed by the US government. But you've got to have 25% of your own money into the program. So you can get a 50% loan, 25% grant, or a 75% grant or loan. Then in Ohio, we also have another program. I'm trying to remember the name of it, but anyway, they subsidize the interest rate by 3%. So you go into a bank, you get your normal financing, and then the state program will actually pay 3% of interest charges. So not 3% of the total, but 3%, 3 percentage points, or what do they say, like 300 basis points, or however financial people like to talk about that stuff. So anyway, so that's a good deal too. You basically, because I was talking to somebody, he said, well, they're giving me a 4% interest rate. So the state's paying 3 out of the 4% interest. So it's almost free money.
Do you know how that works, Jay? Because I remember going into a bank asking about this and they basically steered me away. You know?
Yeah, because the responsibility is the banks. They have to be the ones who work through the program. So you'd have to find out, does your bank participate in this program?
Okay.
I know there was one, and I was trying to remember the name of the bank. It wasn't Fifth Third, but it was one of those kind of banks that do it just as a matter of course. So you might want to call the state program and find out. If you want that detail, I can give you that offline. But
Okay. And do you also know how the PACE loans work?
yeah, PACE is very government local specific. So your local government will have set up a PACE program, which is a property assessed clean energy program. That's what the acronym stands for. And essentially what they're doing is they're saying, in your location, and often it's commercial only, but it can be residential, we will finance the project and then obtain our payment through property tax assessments. So, now it just gets added on to your property tax bill, whatever your annualized payments would be.
And do you know how does that work? Like if you sell your house?
It goes with the property.
Or goes with property? Okay.
Yeah, that's one of the motivations of it. Because a lot of businesses might say, well, I'm a short-term lease or whatever, and I don't know that I'm going to be here 20 years. Well, then you can just finance it with the property. So the next tenant continues to pay for it. It's a leasehold improvement kind of thing. So that's the idea behind it. But your local government has to have passed that.
I've done my research and I found that very few banks will deal with the solar side of it. And the few that do have attached to that. But I found a credit union is the best way to go on this.
Yeah, you may get better financing rates at a credit union anyway. Oh, you know what? The bank in Ohio that does this, Frontier Bank, I was told by them a couple of years ago that they participate in that program. So I think it's called Energize Ohio is the name of the program. All these things are coming back. For some reason, I had a adrenaline shot of youth in my brain here while we're talking. So, okay. So anything else on the financing or those things before I jump into the plug-in vehicle item that came to my attention. Okay, yeah, when I was doing some of the research, I think it was Bruce had sent me through an article about an Australian charging station that is out there in the market. And I know this is near and dear to Tony's hearts as far as plugins, but they were once again advertising that they had a bi-directional plug-in station that was going to be on the market in Australia. And this was for vehicle to grid, vehicle to home. The pricing on this one was much closer to what I would anticipate, which was $10,000 Australian, which is in the neighborhood of what, about 8,000 US, somewhere in there. And so looking into it, the article was interesting because they were talking about some of the regulatory issues that were in play in Australia. But this really pointed out that to use a standard plug for bi-directional charging and discharging. So in case you're not familiar with the terminology of V2G or V2H, vehicle to grid or vehicle to home. So the concept there is if your power goes out, you can use your electric vehicle as your battery bank and supply your home. That was brought up in the Ford Lightning discussion that we had before. V2G is the idea that the utility can then utilize these plug-in vehicles as virtual power plants. So those are the concepts, but there needs to be a standardized protocol in order for all of these vehicles to begin to meet these particular standards. And there was a lot of concern by the vehicle manufacturers saying, listen, if you're just parking your car in the garage and charging and discharging and charging and discharging, and we provide our warranties based on mileage, well, you're not putting any miles on the vehicle, but you're using the battery, which is a significant portion of the vehicle, a lot. So how do we deal with warranty issues? And what happens if you buy a charger that damages our vehicle? How does our warranty deal with that? So there's a lot of issues that still need to be resolved around V2G and V2H.
Jay,
Yeah.
I was gonna say on that very point, the Ford Lightning people, and I know I always talk about them, but you can't even get on the list to get one of them.
Right.
But there was a YouTube video that was done about 2 weeks ago that goes into the details of the charging, of all the, in-the-house charging and stuff. And one of the points they made specifically was that Ford at this point is not going to have their warranty qualified or tied to having it charge the house back and forth. They brought up they talked about that very issue. And they said that for now, Ford is aware of the issue as far as the potential difference in liability for what they're signing up for, but that they are not, they're not going to include any limitations on their warranty for that.
Well, it's funny you mentioned Ford because the articles that I was reading did mention Ford specifically.
Mhm.
And apparently their approach to this, which makes a lot of sense to me, is they're going to have the inverter built into the vehicle.
Yeah.
And so they're going to be exporting AC current from the vehicle.
Yes.
And that gets rid of the whole protocol interaction of charging stations, because you basically come in with AC into the vehicle with your charging, and you leave with AC going out of the vehicle. So everything else is self-contained. And it struck me that seems like the logical future of automobile charging, of EV charging, because AC electric is pretty universal, at least as far as we're, as long as you stay in one country. But,
And they also talked about that, and I guess there's, I don't know how many pins are in the plug-in, but they kind of went through it. There's a top set of pins and a bottom set of pins.
yeah,
I guess they're independent. One is, at least in Ford, one is for charge coming this way, and the other's for charge going out the car.
well, the bottom pins are the DC charge. And the top ones are the AC charge. So they can be bi-directional, but they don't have to be. So if
Right.
you're using a high-powered DC charging station, you've got to have those with the bottom pins that are charging into the vehicle in DC mode. So the way when they're talking about these universal charging stations, they're really talking about DC to DC interaction, because you're taking DC from the car battery
Mhm.
and inverting that into AC for the home. So it's got to have the pin configuration they refer to as CHAdeMO. And that's not standard in US vehicles. CHAdeMO, I thought it's a very weird acronym there, but it actually just stands for charge the motor, CHAdeMO. So anyway, yeah, the only two vehicles currently that are compliant with these chargers are the Nissan Leaf, any of the Nissan Leafs from 2014 and beyond, and the Mitsubishi plug-in hybrids. So those are the only two that allow for bi-directional charging at the moment. Volkswagen announced that starting in 2022, all their future vehicles, their EVs, will be compliant with this standard. But the article went on to say it's anticipated that all EVs by 2025 will be compliant, but they didn't give any reason why they were optimistic for that, which strikes me, cars are not universally compliant with anything. So my guess is they're all going to build in the charging and discharging stations internal within the vehicle. So that would be, if I were laying money on this, I think we're going to start to see AC output from vehicles when you go into a V2G or V2H situation. So I guess we've got a resident expert. I don't know if Tony is listening. He's in the dark there, but Tony, if you're listening, did you have any input on the discussion there so far? He's probably out ordering lunch or something. I don't see him jumping on. Anybody else have any comment on this? Oh yeah, Lynn?
That was accidental. Thank you.
Oh, okay. All right. Okay. The current of these bidirectional, they seem to like to talk about the wall box Quasar, which is a 32 amp system, and it runs between $5,000 and $8,000. So, all right. So any questions, anything else for the good of the cause? That was all I had on my agenda. Yeah, Bill, you've got something?
I want to bring up this question about grow watt inverter chargers again. I'm doing one at 3,000 watts single phase, 120 volts, but I have two friends, both of whom want to explore 240 volts. And in speaking with someone today, this person suggested that the amps on each leg need to be in close proximity. And I wondered whether Siggy might have any comments on that, or anyone else. You know what I mean? In other words, the power on each of the two 120 volt lines needs to be in the same ballpark. Any comments on that? And I guess the other question is, implementing 240 volts simply a question of having two grow watt inverters side by side with a communication wire between the two, and they plug and play. They just start doing what they're supposed to do. Any comments on that?
I think the grow watt inverters, I'm not too familiar with them, but I believe they're putting out to 240 volt split phase, aren't they? Or am I misinformed?
That's what I think.
Yeah. So, so you're concerned about having 120 volts distributed on the load panel? I mean, or what is the issue? I mean, you can have two grow watt in parallel, and they would just putting out more amps in tandem. So I'm not quite sure what the problem would be.
Well, there's no problem. Just someone suggested that the power going across each leg should be in the same ballpark.
Well, I think. you
And of
should-
course, that's load dependent, what you turn on.
Yeah, you probably
It can
always
vary all over the map.
you always want to balance the load between line 1 neutral, line 2 neutral. I think so.
Well, I suggest it's probably never balanced in all of our systems, right?
Well,
I
not
mean,
perfectly, but I mean, you're not gonna put all the heavy loads on line 1 and then none on the line 2, then you're loading up the neutral, I believe, aren't you?
yeah.
Yes.
Yeah, I think the neutral balances between the two legs, don't they, in a typical system?
Yes.
Yeah,
Well, yeah, the neutral takes the unbalanced load. Correct.
right, because I had a situation on our home where the neutral was hit by lightning and blown out underground. And then because of the imbalance of the loads in our home, one leg shot up to like 170 volts and the other one dropped down to about 70 volts. So anything that was connected to the 170 fried out and the others just sort of dimmed or didn't work at all. So that neutral tends to regulate that imbalance, but I know in electricians, they always talk about trying to balance the loads, but you're right, Bill, you can never totally balance them because loads are used sporadically, and infrequently.
Yeah, I'll go out and with a clamp on and see what my imbalance is shortly. I'll bet you could be significant. I don't know.
Yeah, just put a clamp on the neutral, right?
Yeah, that would tell me right there. Yeah. Yeah.
Okay.
Thank you.
All right. Any other questions?
I have one, Jay. I got a question. I've been seeing commercials for a Solaria panel. And what they're touting, I didn't think was an issue anymore, but I just want to check. They're suggesting that most panels today, the panel itself, not a string of panels, but just the individual panel is wired in series. So that if you shade just a 10% of the panel, let's say, the whole panel goes out. Is that correct? Or are most panels more in parallel? I mean, I don't.
No, yeah, typically with, let's just say like an old 60 cell panel.
Yeah.
They're usually going to have 3 strings of 20 cells.
Okay.
With 3 bypass diodes built into the junction box. But what a
Okay.
lot of the panels are starting to do is they're going with half cut cells.
Mhm.
So that the junction box is in the middle. So now essentially they're doubling up the number of bypass diodes. So in that 60 cell, it would be 120 half cells. So
Okay.
there would be 6. So what happens is if one cell's shaded, it's limited to 1/6 of the panel
Okay.
instead of 1/3. So
Okay.
that could be what they're touting, that these are simple half cut panels.
That makes more
which-
sense than
Which is really kind of becoming the norm. We're starting to see a lot more of these split cell or half cut cells
Mhm.
with the junction box in the middle of the back of the panel instead of at the top. And you wouldn't think it would do, but because that junction box is in the middle of the panel, you've now reduced the traveling distance within the panel by 3 feet or so, which
Mhm.
cuts down a lot on resistance and it cuts down a lot on voltage drop within the panel. So you can eke out an extra 0.5% of efficiency out of the panel, for no additional cost.
Okay. And does that also reduce, I guess the commercial kind of just shaded the bottom, 10% of the panel and said, hey, this panel is producing nothing. If you do it with the 6, is it like 3 up top and 3 in the bottom since it's in the center?
Yeah, normally, if I hold this up like it's a panel,
Mhm.
normally the strings go like vertically and then down, and
Okay.
vertically and then down. So if I were to shade the bottom or the top, I'm hitting all 3 strings.
Right.
But if I'm shading here, I'm only hitting 1 string.
Okay.
So it depends on where you shade it, so I'm sure they were trying to maximize the effect
Yeah.
of it.
It was the bottom. They shaded the bottom 10% and just said they're all out now.
Yeah, so in that case, if it was a split cell, now half the panel would be affected
Right. But
because
the other half would still be
there's
going.
6 of those. The top would have been unaffected.
Okay.
Yeah, that's why something like inner row shading is so devastating to the performance of a system.
Yeah, so you've got to
Because-
set those things.
Yeah.
If you've got multiple ground mounted, you want to set them far enough back. Yeah, I've got a good example of a shading on my array. I've got two arrays next to each other and they're not exactly level. So in the early morning, one array casts a shadow on one panel. And I've taken pictures of it. Just that little 1-inch sliver of shade cut the production on that panel by 90%. You know, so it's pretty amazing, the impact of shading.
You got to put up a little mirror to kind of offset it for that first little part of the day.
Yeah, it only matters for about an hour in the morning, so I don't care. It's a good, I did it there on purpose as a teaching technique.
There you go. Exactly.
To demonstrate. So
And it had to be certain times of the year, right?
it had nothing to
Like
do
the
with me
equinox.
screwing up.
So
So
the
actually it was because the ground went downhill and I didn't want to pay for a longer piece of pipe. That was the literal reason for it. Yep.
So the advertised panel, what was it saying? What was its positive?
It was suggesting that maybe I was reading it wrong. It was just a commercial, so I didn't have time to study it, but it was suggesting that they were doing everything in parallel instead of in the series.
No, they couldn't do that. Otherwise you'd have like 0 volts, you know, I mean.
Yeah, that's what I wasn't sure what they were trying to say. They just had the example of maybe it was just the bottom, like you're saying, that they didn't say it, but the top half, they would be half shaded when the other panels were fully, half out, when the other panels were 100% out.
Right. Another reason for these half cell panels is you may or may not remember that in 2017, they changed the NEC code about rapid shutdown to say that you had to limit the voltage within the array boundary to no more than 80 volts. Well, we have these optimizers and things that we're hooking up like 2 panels in series. So you want to make sure that the voltage is less than 40 volts in each of these panels. And if you're going to hook 2 together in a series, because otherwise you'll exceed the NEC's requirement. Well, if you cut that panel in half, you can lower the voltage and increase the amps coming out of each of those panels if you need to. And since panels are getting bigger and bigger and bigger, then we're going to be shooting up against that 80 volt limitation if we don't do something. So I think you'll see half cell, split cell as the norm for panels that you're out buying. And of course, PERC panels, the PERC, I forget, that stands for like passive emitter ray something, but it's basically a reflective coating on the back of the cell that takes the photon and bounces it back up for a second bite at the apple if it's missed. So that's one of those things they've done that is cheap to do and increases your efficiency slightly. So most of the panels we see are going to be referred to as PERC. And if you see that, that's just all they're talking about.
In regards to the rapid shutdown requirement, I just want to add that you got to keep an eye on the temperature corrected voltage. So that adds another 10% to the voltage. And in particular, I've had a couple of projects designed where we're using a Tigo dual rapid shutdown switch. And there are quite a few modules out there that actually temperature corrected get over 40 volts. So if you put 2 in series and put them on a Tigo rapid shutdown switch, then you're actually over 80 volts. So you need to make sure that you select the switch that takes 2 modules in parallel or doesn't add the voltage, not that it basically you need a rapid shutdown switch with 4 inputs, plus minus, plus minus. I'm just wanting to point that out. So.
Yep. Well, if you attend the Tigo seminar tomorrow, you'll learn all about that.
Yeah.
Okay. Anything else before we call it a day?
Hey, you're going to send us the links for those seminars, Jay, in the email?
Yeah. If you could just send me an email asking,
that.
I'll go ahead and forward them on to whoever's interested.
Excellent. Thank you.
All right. Okie doke. All right. Well, take care. Talk to you guys next week. All right. Bye-bye.